I know it's been some time since I did the last video. Right now I'm working on an NFS client and working on debugging it. And it needs to read from a network, and that I/O is buffered, of course. And since I'm writing C, I wrote some functions that make it easier for me to deal with network packets, and they abstract around it a little. In any case, right now I'm at a position where I have to debug this particular thing. Yes, I can add a watch, that's nice. So I can see that there is this function called buffer left that tells me how many bytes of the network buffer that I have are valid at a particular point in time. And I can also call that function myself. I can just put this into an expression watch, and if nothing is too bad, I should be able to look at that. Apparently I cannot. Which is interesting. So I can put a watch on this place where I call the function, but I cannot put a watch on where I actually call it. Well, if that's the case, then I will have to go to the shell micro NFS, build it with debug information and without optimization, and then should have a function should have an executable nfs-ls, which runs essentially an ls command on a remote. And sometimes it succeeds, but sometimes it does not, depending on how much you get from your network, depending on whether the frame is full at a particular point in time or not. So what I can do now is I can look at D, which shows me how much is there to read. Then it depends on where the read pointer is in relation to the buffer pointer. And then, so the fragment size shows me how much of message I am still expecting. And the other, so this serializer buffer, I can call it buffer left. If I do this, if I just call that on my buffer, I can see that that there are minus 8 bytes left, which means that the last time I wanted to read something, I didn't make sure that I had enough bytes read for that I have enough in my buffer. And the way I ensure that I have enough bytes in my buffer is by using RPC serializer ensure size, which will check if there's enough bytes in the buffer, and if not, it issues another receive command. And it will also tell me if I am requesting more bytes than my message actually has. So let me see how much I have in my buffer right now. There we go. So right now I have like 1,000 thingies in my buffer. So I let it continue. Continue. And then the next time I'm reaching this place, which is here in line 522, suddenly I have a negative number in my buffer, and that is fairly strange because I only expect to have 84 bytes in my attributes. So what's going on? Let me redo this experiment, and this time we step through. Oh, this time the breakpoint wasn't set. Or was it? B516. Okay, now I enabled the breakpoint again. Essentially, I rerun this. I look at how much there is left in my buffer. I have like 3,000 left in the buffer, so the file iteration function should go through without any issue. So I say continue. I hit my breakpoint again. Again, I have lots of buffer left at this point, but you can see my fragment size. Now it has dwindled down, so I can only have one more full reload of the record in my buffer. So let's see how much I've left. I have left quite a lot. I've left 1,000 something. So when I now step, and now I should have read 4 bytes. So now the 160 should be 156, and it is. Now I do next, I should lose about 80 bytes of my buffer. 84 bytes, just the size of the attributes that I'm reading. I go next. I go next. Now this is the place where I usually hit the assert, so I check how much I have left in my buffer. I have quite a lot left. So I go next, I go next. I should now have 1068. That's true. And now it reads a file handle. And we're going to step into this because reading a file handle consists of doing multiple things. So first off, I ensure that I have the 4 bytes for the length. Then I read the actual length. Let's look at the length of this following string. It says it's 12 bytes big. Let me have a little look at my read pointer. And in this case, I should be able to cast it to a const star. And this is interesting because this does not look like a valid read pointer to me. I would expect in this inline storage, right now I'm at a place where I am expecting a directory entry to be, but there is not. So what's going on? Oh, right. No, I do not expect it to be where a directory entry is. I expect what follows to be file handle. And that's 12 bytes long. Yeah, that's fine. That's actually not that much of an issue, but I think that I've already went through here. Okay. Now resolve. We can see that there are some bytes in this file handle, and after a while there are only zeros. So I guess that's fine. And at the same time, I increase the read pointer, but it did also ensure the size. So right now my buffer left self. Okay, if that's still fine, that's a reasonable value. I can go to the next step with that. This again is now address of D again. A readable if there is a next one. Ensure that I have enough size for the buffer. I now look at the name length to ensure that this is like a reasonable value. The name is 2 bytes long, which I would expect expect is maybe dot dot. It's a fairly common name that's 2 bytes long, so let me go through that. So after I did read string, I say name, and the name says it is HRML. This is strange. I could have sworn I saw name length 2 over there, but apparently it was name length 4, and the name was HRML. That's fine. I have a reasonable number in my buffer left. So I can go to here. I hit this breakpoint. I ignore this breakpoint. I look at how much is left of my buffer. It should still be a reasonable number. It certainly has the 84 bytes that I need for the file attributes. The file handle also looks... Actually, this one looks kind of funky, but I guess I can leave that as it is, because I'm not debugging the actual content. I'm looking at how much of my buffer is left. It looks like the reload went fine. Again, I have a reasonable number on how much of my buffer is left, but I think there shouldn't be much left of the fragment at this point. Now the name length is 2. And the name is dot dot, which is a reasonable name to be having. However, right now we are exactly at size and max buffer are the same, which means I think that I'm not sure if I recall correctly whether size was the size that is left. Or I think size gets reduced. If I step into buffer left, you see that it takes size as how much there is in the buffer, and then it looks how far the read pointer has advanced in the buffer. So this is how much I have, and this is how much I have advanced. So size is the amount of bytes that are filled in during my last call to receive. It tells me I have lots of bytes left. Now, after reading the trips, that should have reduced by 84. So it will be 1000 something. Do a read file handle. Check the size of my buffer again. It's completely fine. I go through whatever the file iterator does. Now I should have lost 4 more, so I should have 1040. Well, now I should have 1040. Alright. Make sure that that's enough for there. I think there are 11 bytes. Look at the name. Looks like a reasonable name. Check my buffer. Reasonable. The buffer is still reasonable. I wonder if I can do a breakpoint with condition. Let's say break if this is less than 0. Maybe I have to call this a watch. Well, I set it as a watch point, so this should trigger as soon as this condition changes its truth value. You can see how stepping got lots slower, and now we're actually at a point where there are 0 bytes left in our buffer, and we're about to read a Boolean value. this should be impossible, since right here we ensured that there would be 12 bytes in our buffer. However, once we step over the following line, our buffer left variable will go negative. Watch. Interesting, it did not go negative. Okay, that means we were able to reload. And now we have a change. This value, how much we have left in our buffer, changed just now. Why? Because we changed the size. So this line was executed before our watch point triggered. Let's see how many missing bytes we have, if we have anything at all. We have about 1,000 missing bytes. That looks strange. Oh. And we can see that the fragment size left went negative. And that means that we just received more bytes than we were assuming are in this buffer. And that happened during a read of this file handle. Let's see, maybe we can see the name, right? It happens when we read this HRML txt. The question is now, we now see that we got in a completely unexpected situation, which is always what happens when you have these bugs. And the unexpected situation was that we received more bytes than should have been in the message we were expecting. We looked at how many bytes we received. We received 328, which is, yeah, like I said, more than we were expecting. But the only way we could receive more than we were expecting is by asking for more than we were expecting. So we are always asking for the maximum that'll fit in our buffer. And this is problematic when the network packet we get is too big. It is as if there is data either that we don't expecting, or we're getting bytes that are meant for a different connection. To be able to say anything about that, we need to look at Wireshark. Just do this. Like that. Okay. Now we start listening on our network interface. We filter for NFS. Since I don't particularly want to show you how much is going on this network. There we go. So we can restart this. It will take ages because I have a watch point set. Or I can just run this, but I should put a watch point first. Let me do B512 here. I'm not quite sure where this will land, but it will land somewhere close to where I want to stop. Because then I can now put my watch point, D dot fragment left. Fragment has left. I want to know when this goes smaller than 0. That's it. Continue, please. D1. So deleting this particular breakpoint. Our watch point still, and it didn't trigger. This is interesting. So I aborted with this assertion. I just did that. So here I can look at the deserializer object. And I can look at fragments as left. Well, since this whole watch point thing doesn't seem to be super reliable, watch self fragment says left less than 0. Rerun the thing. Will it show watch? Was it p info? Was it info? I think it was info. Watch points. No watch points. Okay. I'm at a place where the size I've left in my buffer is negative. And at the same time, this happens after reading the file attribute pointers. But now that I know that this fragment size left can go negative if you receive more than you think, that is what I need to be able to put my breakpoint on. And I don't particularly want to play around with the watch points right this second. Right here I can say the read network things. The last one that I received was one that shows me the content of one of my projects that are in this directory. That makes sense. Complete sense. But what I said was I didn't want to play with this watch point right this second. So what I can do, so I can simply go into this function I can go to the implementation and I can simply ask whether I have received more than I should have received. So if cell fragment says left is less than the bytes that I received, then I want to trigger a breakpoint. There are a few ways to trigger a breakpoint in a semi-portable way. And this is one that I know for x86. So I think I wrote this correctly. So now if I run this, then I should get a breakpoint, and I do. I forgot to do a build with so this is fairly interesting. Because now I can actually look at the values that I get right before the receive. So I can now look at how much I received. I received 328 and I'm only expecting 324. So that means either the size that I think I should receive is wrong. Well, that's actually the only thing that can happen. So I see a last fragment here. It's a reply to a message sent with 0000, which would, oh, that's actually correct. So I didn't set this to a proper transfer ID, but it doesn't seem to matter that much. So this request has 1784 bytes, which usually I would assume that fits into my buffer. And I do wonder why it doesn't. Maybe I took a different size. There should be a size defined inside the H file. And here, which is the size of the inlet storage, is 1460. So now we can simply do the computation ourselves. We take the size of the message, right, the fragment header. It's 1784. That's the fragment size left that got set when I got my first receive. 1784. Is that correct? Yes, 1784. And we subtract the size of how much would have fit in the first buffer. And we end up with 324. Okay. And we would have received that much because we try to make sure that we get the full buffer worth. This is why we have this missing bytes, and we compute in missing bytes how much we are missing to get to the full buffer size. And if we are missing something to get to the full buffer size, and we have more fragments than we are missing bytes, we will issue another receive call with that. Now I can already see a problem with this. Which is that this expression may not say what I think it says. It might be that the end binds like this. So I would have an if 1 is greater than missing bytes. But if that were the case, then you would have always almost never hit this. So no, the interpretation seems to be correct, but I should put proper parenthesization of this expression to make sure that that is indeed what we get. So yeah, for some reason, so the fragment size we compute, we just computed over here how much we think we have left, which is 1 full buffer minus the size that we got here. Is too small. We are being told that the bytes we just received were more than we expect to be in this message. Okay. One thing we can do is simply print out what the return value of receive is every time we do call receive. And it will complain about me not importing stdio here, but I don't want to import stdio here. Refill receive, but just receive bytes. Luckily I can do this without importing stdio, since it's a function that gets passed in a way that doesn't depend on your types. Where the parameter gets passed in a way that doesn't depend on the types, since it's a variadic. So that'll work. And right here we have a place for call receive. And I'm not quite sure why I don't call this received bytes. Maybe because I don't want to override this as the value, but at this time refill receive, let's call it refill receive again, since this might have something to do with what's going on. Alright, now we have the printout. We can simply run this. Okay, so we have an initial receive that receives some number of bytes, and we have an initial receive that receives the full buffer. Then we have a refill receive that receives 4 byte more. So I do this question here. How much can I receive from my socket right now? And for some reason I'm getting more than I'm expecting. This is weird. And I don't know what happens. This is quite strange. Anyways, I'm at 1 hour, and for now this shall be enough.